So this is lesson 54, B as in boy, and we're continuing on with changing from polar to rectangular, and they give us one for our second example of 230 degrees. So 7 at 230 degrees here. Okay, so let's put our rectangular system on here. And let's put that point on there. 230 degrees. 230 degrees. Let's see, that's 180 degrees. So that'd be another 50 degrees here, right? So, and that's 7 long, and that's 230 degrees. Okay, so let's draw our triangle. And we're looking for those two red lines. So we're looking for our x and we're looking for our y value. Alright. One of the things when it comes to doing trigonometry, and when you actually take trigonometry, for most of you it will probably be spring of next year, not this coming year, but next year. And one of the things that you'll find is that when you take trig functions like the sine, if you took the sine of 230 and you also took the sine of this angle right here, which is just a 50-degree angle, you would find out that those are going to be the same. There's no difference between them. And the reason for that is because 230 minus 50 is a 180-degree angle. And when the difference between the two angles is 180 degrees, at least in this case, or it could be that it's 360 or 0 or whatever. Anyway, if in this case it's 180 degrees, the difference between those, then the trig functions will be the same. So the sine of 230 and the sine of 50 are going to give you the same number. So one just might be negative, one might be positive. But anyway, that's what we're going to do is when we're looking at this one, though. Because what we do is we're looking for just this triangle. We don't care where that triangle is. Alright, we just are interested in that triangle. So I'm interested in this angle here. Because when you use trig functions like the sine, what am I interested in? I'm interested in the sine of this angle of the triangle. This one, yes, 230, but I just used the 230 in order to get this triangle, so I know where it's at. So that is a 50-degree angle because 230 minus this 180 gives me this angle right here, and that's what I want. So when I am looking for the x value, this length right here, I am going to write it as x equals, no, we don't need this anymore, x equals the hypotenuse cosine of theta, which in this case is going to be 7 cosine of 50 degrees. My y value is going to be h sine of theta, or 7 sine of 50 degrees. So when I take the cosine of 50, multiply it by 7, and sine of 50 and multiply it by 7, I'm going to get 4.48, and I'm also going to get 5.39. Now let's look at see where those are. In order to get those, and I'm not sure what your calculator will do. Some calculators will make this negative, some won't. But let's look and see where this point right here is. We had to go over to the left, 4.48. So that's actually negative 4.48 on the x-axis, right? And this is negative 5.39. So when I write this in rectangular form, I had to go over x, so I went to the opposite of right. So I'm going to say it's right, but that means I went the opposite direction. And I'm also going to go down, or the opposite of up. so then I can switch those around and get negative 4.48r minus 5.39 up. And that ends up being the answer to that problem. Okay, so hopefully you've kind of gotten an idea of what's going on here. Well, let's do one more. Okay, top of page 235. We're going to change 42 at 340 degrees. Alright, so let's see. 340 degrees is all the way around here. 20 degrees shy of 360. So that's 340. And then I draw my triangle. And I'm trying to find this, and I'm trying to find that. My x is going to be positive, my y is going to be negative. Okay, so lots of information there. If this is 340, then this angle here is 20. So that's the angle I'm going to use, and this is 42. So, in order to change that to rectangular, I'm going to find the x value, I'm going to take 42 times the cosine of 20. And to find the y value, I'm going to take 42 times the sine of 20. Okay, not too terrible. And when I solve this, I'm going to get my x value of 39.48, and my y value then is going to be 14.28. Now the reason I had to draw this is so I know what quadrant it's in. In this fourth quadrant here, I know that my x value is positive and my y value is negative, so that's how I have to write that. Even though both of those are positive, when I write it, I have to write x is positive and y is negative. Opposite of up. Okay, so this really is, plus negative, but we just wrote it as negative there. And that's it for 54.3. All right, let's look at section 54 on similar triangles next. So similar triangles are pretty basic. The only thing you need to remember when you're comparing these two triangles, this triangle here with this triangle here, is which sides of the triangle are corresponding. Okay, so you got to look at what you know. We know this angle and this angle. So the adjacent side right here, A, is going to correspond with this one because they're both connected to this angle here that we know are the same, and it's not the shorter of the three. So I know A and B are corresponding. I also know then that C and D are corresponding. So what I'm going to do here is I'm going to write it this way as far as solving for one of these angles. In fact, that's all this part of the lesson is doing, is solving for one variable. So let's say that in this particular one we're trying to find out what D equals. So we're going to write this. You can write this since A and B are corresponding, we can write it A is to B as C is to D. So notice on the top is the triangle on the left, on the bottom is the triangle on the right, and we get AD when we cross multiply, divide by A, and that cancels that, and that gives me D equals BC over A. Okay, so that's one of the ways you can do it. You can also write it as AC equals BD. And what we did is we put the corresponding sides on the top and the other corresponding sides, in this case the hypotenuses, on the bottom, and we can cross multiply. Divide by A, cancel, and we get the same thing. So it doesn't matter which direction you go. Whether you decide, like some students want, the left triangle, I'm going to put the sides on the left. the right triangle, I'm going to put the sides on the right. So as long as A and B are the corresponding ones and C and D are the corresponding ones, it doesn't matter. And it doesn't matter if the CD was on top and the AB was on bottom. As long as you focus on, especially on this one, that A and C are in the left triangle, so they go here. So you could have written it as C over A, and then over here B and D are over on this side. You could have written this as D over B. But if this one was flipped, this one also has to be flipped, so that your hypotenuse, C and D, are on the same level, whether they're both down here or both up here. It doesn't really matter. And that's it for 54B.